information, make sure that this information remain in your mind, so that at least you can be able to carry them forward next time if a question come on the same line. So this time, all this in this period, we have discussed so many topics. And we have 3 questions remaining in section B. So we are going to discuss all of them right now. So I request you to pay maximum attention, please. So question number 11, sorry. Let's look at question number 11. Question 11. Question number 11. Which is basically on 3 set problems. Well, remember, we look at 3 sets problems. 3 sets problems. And we discussed those one at length the other time when we met. We discussed them at length. So I believe by this time there should be no question on that. And how we interpret, the interpretation of questions is very important. So when a question is 3 set problem, they're always given in statement form like this. So when a question is given in statement form like this, now is upon you to change it from the word problems, into the set language. You have to change it to the set language. So you have to be very careful when changing them to the set language. You must pay attention. To how the questions was given. You have to pay attention to that, please. Okay? Are we together?
Yes.
Yes. So like when we look at this question, that said in a class of 69 students, what is that going to present? Now we are changing them to set language. What is that going to present?
Universal.
That one is going to give our what? Universal. Wait a minute. Let me connect my camera. So that's going to give us the universal. That is good. So our universal, solution. Our universal was given to be 69. Each of the students, at least each of the students plays at least one of the what? Of the 3 games. What does that one mean? Who can give me the interpretation of this? Each of the students plays at least one of the 3 games, which means all the 69 at least belong to, which implies that number A union B union C complement, which is the same as number A complement intersection B complement intersection C complement is equals to what? Is equals to 0. Which means at least all the 69 must belong somewhere, to somewhere. And what are these 3 games? We have basket, which they have used letter B. We have rugby, which they have used letter C. Then football, which they have used letter A to present them. So tomorrow they will give you a question which is general. They may not define for them which letter to use. So it's incumbent upon you now to pick which letter to use to present a given set of values. So now we have 20 students play football only. So this one is the same as number A intersection B complement intersection C what? Complement, which is the same as number A only was given to be what? 20. was given to be 20. Then 12 students, 12 students play basket only, which is the same as number A complement intersection B intersection C complement, which is the same as number B only. B only is 12. B only is 12. Then they've also said 15 played rugby only. So number A complement intersection B complement intersection C, which is the same as number C only, is equals to 15. Is equals to 15. Then they've said five students play both. Play football and rugby only. So this is the same as number A intersection basketball intersection, this one complement, which is the same as number A intersection B only, which was given to be 5. Which was given to be 5. Then 6 play basket and rugby only. Basket and rugby only, which is the same as number A complement intersection B intersection C, which is going to be the same as number B intersection C only, was given to be what? 6. Members, are you following me? Members, are you following me?
Yes.
Good. Then I've said X students play basket and football only. So which means number A intersection basket. Sorry, A complement. This one should be A complement. A complement. X play basket. Basket is B. B intersection football. Oh, sorry. This one should not be complement. Then C complement. C complement. Let's see. X basket. Basket is B. Then and football. Are we not repeating ourselves? This 5 was presenting what? What was this 5 representing? Football and rugby. This one was supposed to be complement. Then this one is open. Sorry. This was supposed to be C. This was C. Change that. Then this is it. Equals to number A intersection B only, was given to be X. Was given to be X. While Y students play all the 3 games. So number A intersection B intersection C was given to be what? Y. Was given to be Y. So after, there's mark for collecting this information. So a student who have collected all this information and interpreted it, put it in a set language like this, you get B1. You get bonus there, 1. Then after this, now you go and draw a Venn. You go and draw a Venn what? A Venn diagram. You draw a Venn diagram. Then after you use it to answer any other question that comes. So can we draw the Venn diagram now? Please don't use a free hand because I'm using a free hand. So if I leave it like this, have I drawn a Venn diagram? No. A Venn diagram must be enclosed with a rectangle. A Venn diagram must be enclosed with a rectangle. A Venn diagram must be closed with a rectangle. So if you draw only the circles without enclosing them, that is not a Venn diagram. You have drawn something else. So that's what we have. So I put the number of universal, which is 69. So this is number of basket, football. This is the number of basket. This is the number of rugby. So let's start entering the information one by one. So they have said A, so there are none. A union, A complement, A complement, intersection B complement, intersection C complement is 0. So where are we going to put this one? This one we put it where? There. So we put 0 there. Then A only was given to be 20. Then B only was given to be 12. Then C only was given to be 15, like that. Was given to be like that. Then A intersection C only. A intersection C only. A intersection C only was given to be 5. Was given to be 5. Then B intersection C. B intersection C was given to be 6. Then A intersection B was given to be X. Was given to be X. These are only. Then all student will play only 3 games. They are Y. So we put Y. So this one they already only. So there's no, you don't subtract when they have said only. You don't what? Subtract when they have said only. So which means X only, 5 only, like that. So now the only task now we have is to find the value of X and Y. How are we going to find the value of X and Y? But if you look at the question here they have given us here, represent this information on a Venn diagram, which we have done, given that they have given us that. Let me write it here. They have given number A intersection B plus number B intersection C plus number A intersection C must be equals to 20. Must be equals to 20. That information is very important. That information is very important, which means if I add this one, and this must give me what? Must give me what, members? Must give me what? Must give me what? Must give me 20. So, which means A intersection B, which is X plus B intersection C. What is B intersection C? Which is 6 plus A intersection B, which is 5, must give me what? Must give me what? Must give me 20. So from there, we can even find the value of X. So can we find the value of X from there? So which means I'll have X plus 11 equals to 20. So our X will be equals to 20 minus 11. Therefore, X is equals to what? X is equals to what, members? X is what? X is what?
9.
Our X is 9. Members, have you seen that? Have you seen that?
Yep.
Okay. Now, do we stop there? We also have to find the value of Y. Are we going to find the value of Y? Who can tell us what are we going to find the value of Y? Are we going to find the value of Y? We have already got the value of X using the information they've given us. Are we going to find the value of X? I mean of Y, sorry.
We add all the items.
We add all the items. Good. We add all the items. It must give us the what? It must give us the universal. It must give us the what? The universal. So we shall have using universal, using the universal. So we shall have 20 plus X plus 12 plus 5 plus Y plus 6, then plus 15 must give us 60 what? Must give us 60 what? 69. But we have already got the value of X. So can we just substitute for X? But X is equals to 9. So it implies that we shall have 20 plus 9 plus 12 plus 5. Let me collect the items. Plus 6 plus 15 plus Y is equals to 69. So can you add for me all that? What do you get? When you add all of them, what do you get? 20 plus 9 plus 12 plus 5 plus 6 plus 15. What do you get? 60? You get 60 what? 67. So 67 plus Y must give us 69, which means our Y will be equals to 69 minus 60 what? Minus 67. Therefore, our Y is equals to what? Our Y is equals to? Our Y is what? Our Y is 2. Is there any unknown we have not yet got? Is there any unknown we have not got? We have got all the unknowns, not so?
Teacher,
Yes?
when you were finding the value of X,
Yes.
where did that 20 come from?
Then it was given in the question. Are you seeing this in the question here? Given that number A intersection B plus number B intersection C plus number A intersection C is equals to 20. Are you seeing that information?
Yes.
Yes, it was given in the question. It was given in the question. Okay. So
Yes.
when you add A intersection B, which is what? A intersection B is what? X. B intersection C is what? Is 6. A intersection C is what? 5. So when you add this to give you 20, you find that we can get the value of X from there, which would be 9. Lynette, have you got it now?
Yes.
Okay. So we have got all the unknowns. After getting all the unknowns, draw another Venn diagram. Draw another Venn diagram. A clear one. Some of you again will come and start putting X and then 5, 2 here. Don't make your Venn diagram look dirty. Make your work to be organized and smart. So let's draw another Venn diagram here. Let's draw another Venn diagram there. So this is number of A. This is the number of B. This is the number of C. Then here was 0. Here was Y, which we got is 2. Here was 5. Here was X, which we got is 9. Here is 6. This is 20. This is 12. This is 15. So this one, there's no any unknown there. So let's first find the number of how many students played football. So how many played football? So you add all this set. Add all of this set. Add all of this set. So when you add all of that set, what do you get? 20 plus 9, that is 20. 29. 29 plus 2, that is 31. 31 plus 5, that is 30. 36. So there we shall have 36. Then 9 plus 12, that is 21. 21. 21 plus 6, 27. 27 plus 2, that is 20. 20 what? 29. 5 plus 15, that's already 20. 20 plus 2, 22. 22 plus 6, that is 28. That is 28. So we have got all the information. We have got all the what? All the information. So can we go ahead and answer the question now? Can we go ahead and answer the question? In part B. In part B, they're saying find the value of X and the value of Y, which we have already done. Part C. In part C, they want us to find the probability that a student chosen at random plays more than one game. Plays more than one game. We know that probability of any event is given by the number of events divided by the number of sample what? Sample space. And what is going to be the event? The event this time is more than what? More than one game. So which one are we going to add? More than one game. So which means we are adding. So this, because here we have 3 games, which means a student can play only 1, can play 2, or can play all the 3 games. That's what it means, more than one game. So which means you're adding 20, you're adding this, 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 and you're adding that. Are you seeing that, members? So you have 20 plus 9 plus 12 plus 5 plus 2 plus 6 plus 15. Everything divided by the universal is going to be the sample space, which is 60. Which is 60 what? 69. So when you add all of this, what do you get? When you add all of that, what do you get? You get 60. 69 divided by 60 what? 69. So what's the probability, members? What's the probability? What's the probability?
1.
The probability is what?
1.
1. Good. Because even you can see from the statement I've given here, they said each of the student plays at least one of the game. which means there's no one who is not playing any of the 3 games. At least one must belong to any of the must play one of the games. So the probability is what? 1. Which means the chance of you picking a student who play at least more than 1 game is very high. Is very what? Is very high, and is 1. And you are setting that at least when you pick any student, you will get someone who will play one of the game. D. What about in D? What about in D? What about in D? Indeed, they're saying find the probability that a student chosen at random play at most 2 games. So here the probability of at most 2 games. At most 2 games. So which one are we going to add? At most 2 games. What does at most means? Which means someone can play 2 games, can play 1 or none. You play 2 games, 1 or none. So which one are we going to add? We are adding this section here, where you seeing my red pen is. We are adding. This is where we are. This is what we are adding. Okay. So we shall have 20 plus 12 plus 15 plus 5 plus 9 plus 6 plus 6. Everything divided by 69. Everything divided by 69. So when you add that, what do you get? When you add that, what do you get? Even you can say plus 0, but it will not change anything. This 0 here, this one here, this one here. So when you add that, what do you get? When you add that, what do you get? We shall have 20 plus 12 plus 15 plus 5 plus 9 plus 6. Members, what do you have?
67.
So 67 over what? 69. Are there common factors there? Are there common factors there? No. You leave it like that. Or you can put your answer in decimal point. So what is 67 divided by 69? You get 0.971.
0.97110.
This one to how many decimal place? 2?
4.
To 4. That one is also accepted. That one is also accepted. Okay?
Yes.
Yes. What if the question was asking? Let me just add this one now. What if the question they were asking at least 2 games? At least 2 games. That a student taken at random from the group or selected at random from the group play at least 2 games. So which one are we going to add? At least 2 games. We are going to add 9, not so? We are going to add 5. We are going to add 6, and then we are going to add 2. Have you seen that, members? Have you seen that? 2 or more, at least 2 or more. 2 or more. So in this case, we have only 3 games, which means a student can play only 2 games or only 3 games. Only 2 games or only 3 games. So which means we are going to have 5 plus 6 plus 9 plus 2 over 69. So what do you get there? What do you get there? What do you get? This is 11, 20, 22. 22 out of 60 what? Out of 60? Out of 69. Is that correct, members?
Yes.
Are there common factors in them? No. There's no common factor there. So that's our question I said. That's our question I what? I said. Members, is there any question there? Is there any question in number 11? Have you understood what was required of you? Members, is there any question on that? We are together, right?
Yes.
And you have understood. Good. Okay, let's go to number 12. Number 12. Let's go to number 12. Question number 12. And question number 12, that was coming from matrices. It was coming from matrices. It was coming from matrices. We said matrix is the array of information in row and column form. In row and column form. So suppose I have matrix A. Before we get in details of that question, suppose I have matrix A, which is given in the form A, B, C, D. The matrix is written in capital letters, Then the element can either be letters or numbers, And the letters, if you are using letters, the letters must be in small letters. They must be in small what? Small letters. But the matrix must be in capital letters. But the elements, A, B, C, and D, they are called elements or members. They are called what? Members or elements. So when you look at this, you must also know how to interpret matrices. You must also know how to interpret. We talk about the order of the matrix. We talk about the type of matrices. We talk of multiplication operation of matrices. We talk about multiplication of matrix by a scalar. We talk of matrix as a store of information. Like now, this question that I've given you is a matrix. We are using matrix as a store of information. And matrix help us to solve very many problems in real life. And I believe by this time you should know how to use matrices, even in solving day-to-day problems at home there, like collecting data. You can collect data in any form and you put them in it, like the shopping list from home there. For those who have a farm, you can even talk about how you collect the what? The eggs, how the milk. You can put them in a row and column what? Form. I together members. For those who maybe after the lesson you attend shops, the shop attendants, you can also the daily sales, you can put them in what? Row and column form. You can put them in matrix form. You are solving problems using mathematics. That's why we teach them. We don't teach them just for the sake of teaching. It must be in position to solve problems in real life. Yes. Are you together, members? So all these, they have names. This one, along this, we have this one. This one is called a what? This one is called minor. It's called minor what? Minor diagonals, not so?
Diagonal. Yes.
Then this one is the
measure.
This one is the major. This is the major diagonal. Now, what is the order of this matrix? What about the order? What is the order? How many columns matrices? Order of the matrix is given in the form. Order of the matrix is given in the form row by column. Is row by what? Is row by what? Column. So like when you look at this matrix A, B, C, D, how many columns? How many rows does it have? How many rows? Rows are like this. So how many rows? How many rows? There are 2. So it becomes 2 by how many columns? How many columns? There are 2. There are 2 columns. So it becomes 2 by 2 matrix. The order of a matrix is very important, members. It's very important because it helps us in multiplication of matrices. It helps us in multiplication of what? Matrices. And we said for you to multiply any matrix, to multiply any 2 matrices, they must be compatible. They must be what? The compatibility of matrices. The compatibility of matrices. They must be compatible. Say, for example, if I want to say a matrix A, matrix AB. Suppose A is of 2 by 2 matrix. A is a 2 by 2 matrix. What I may say B is a 2 by 3 matrix. So if I'm multiplying these matrices, I have to look at the order of the matrix for me to go ahead. Otherwise, they become practically impossible to multiply them. What do we mean compatibility of the matrices? So like this one, A is a 2 by 2. Then B is a 2 by what? Is a 2 by 3. We look at the adjacent order. Which is this one here. I think that, members. So the number of columns in the first matrix the number of columns in the first matrix must be equal to the number of rows in the second matrix. So like when you look at this one, are they the same? Are they the same?
Yes.
So when you look at this matrix, are they compatible? Are they compatible, members?
Yes.
They are compatible. Good. Because this number of columns in the first matrix is equal to the number of rows in the second matrix. Why do we say that? Because when we are multiplying matrices, we multiply row by column. We multiply row by what? Column. So which means for you to multiply correctly and accurately, they must be of the same order. They must be the same. And that one now, the answer we are going to get is going to be determined by the remaining one. It's going to be determined by these two, this one here and this one here. So which means the answer we are going to get must be of which order, members? It must be of what? Must be 2 by 3. Must be 2 by 3 matrix. Are you together? But if you are multiplying square matrices, if I talk of square matrices, I'm meaning matrices with the same order, with the same number of columns and with the same number of rows. So 2 by 2, and then you are multiplying it again. If A is 2 by 2, even B is 2 by what? 2 by 2, which means the answer we are going to get, the answer must also be 2 by what? Must be 2 by 2. 2 by 2. Is that clear, members? Is that clear?
Yes.
Now, after that, after we have understood that, now let's come back to our question now. The question is given in information form, in statement form. So we have to interpret it and then we put it in a given order of matrices. In a given order of matrices. Who can take us through that question? Who can take us through that question? Who can take us through that question? You talk if you know you have good network. Some you have bad network. Then you start making funny sounds.
A poultry farm has 3 poultry units.
As how many units? A, 3. B, and then what?
C. Unit A produces 30 trays of eggs.
Now we have how many items from each farm or from each unit? We are producing how many things? We are producing 2 things. We are producing eggs, and then we are producing what? Broilers, not so?
Broilers.
So
yes.
we have eggs, which they are put in terms of trays. Then we have what? Broilers.
Broilers.
So in unit A, these are the units. In unit A, how many tray of eggs do we produce from that farm?
30.
There are 30. How many broilers?
20.
There are 20. What about farm B?
40 trays.
40.
Of eggs. And 15 broilers.
Are you seeing how I'm presenting mine, members? Are you seeing how I'm presenting mine?
Yes.
Then what about unit C?
35 tray of eggs.
And
10 broilers.
And 10 what? Broilers. So it means this line is presenting what? The row here is presenting what?
Eggs.
Eggs.
Tray of eggs.
Then here is presenting
broilers.
Then this one is presenting the units. This is present the units, not so?
Yep.
Yes.
In its simple terms, the way we are put it, that one is already a matrix. It's already a matrix. But the question is, a matrix must be enclosed with a rectangle. A matrix must be closed with a what? With a rectangle or a closed bracket. Are you together, members? Are you together? Yes. So when you leave it like this, this is not that a matrix. But by the nature of, by the look of it, it may appear to be like a matrix, but it's not yet a matrix. The only thing missing here is a what? The only thing missing is a what? A rectangle or a bracket. So we have less than a minute, members. If we get done, we join back. Okay? Okay?
Yes.
Yes.